great. Yeah. Awesome. Okay, welcome everybody to, I think we're in week 22 or something like that of the WESTalks presented by University of British Columbia and McGill. Right, I have to click on there. Right, well, I'll quickly read through. I see Impacts as a pan-Canadian, the Canada-India Research Center of Excellence. It's hosted at UBC. And then the UBC Future Waters, and kind of newly forming the UBC Future Waters student group as well, is a research cluster at UBC, and we're trying to unite all the water research students from across campus who are not just engineers, but anybody related to water research who just wants to collaborate and learn alternative perspectives. So, the organizing committee, as always, Abhishek, Jaskaran, Fuhar, myself, and Furia. And we've recently, Layli has joined the team as well, so I need to get her picture on here too. But welcome, Layli. All right, so here's the lineup. Here's where we've been through this fall. And today we're at Dr. Andrew Whelton from Purdue, and we're looking at disaster challenges and opportunities. So as always, the previous WESTalks are all available on the IC Impacts YouTube. So just go to YouTube and search IC Impacts, or even just search WESTalks. Both of them work. And now on to today's speaker. So Dr. Andrew Whelton. So Professor Whelton has 20 years of experience in the infrastructure, public health, and environmental areas. He is nationally recognized for water infrastructure disaster response and recovery, among other expertise. His teams have been called to help respond to and recover from widespread water distribution and building plumbing contamination in response to the 2014 MCHM chemical spill, the 2017 Tubbs fire, 2018 Campfire, and others. And he did send a list of other, quite long list of things he's done and helped out with. Professor Whelton previously worked with the US Army, which we were discussing a couple minutes before the talk started, quite interesting. The private sector, the National Institute for Standards and Technology, and the University of South Alabama. He earned his bachelor's in civil engineering, master's in environmental engineering, and PhD in civil engineering degrees from Virginia Tech. And then there's a website there at the bottom, which is his group's work. All right, and with that, I will stop sharing and we'll hand it over to Dr. Whelton.
All right, so thank you so much for the opportunity to talk with you today. Let me put this up. And, you know, this is fantastic. So it's about 12 o'clock here, midday. It's the last week, basically, of the semester. So I'm sure you all are Zoomed and WebExed out. So if you listen to this later, that's okay. If you do have questions, though, that you want answered, maybe put them in the chat box. And we can talk about it after. You don't have to wait until the end to post them in the chat box. So thank you again for the opportunity to talk with you all. What I'm going to tell you a little bit about is you know, what we do and some of these issues that you really can start helping with. You know, it's best, I believe, for students and professionals to understand how it is operationally in a disaster environment and why things happen. And generally it's because of poor planning or good planning or you know, learning on the fly. And there's a lot of opportunity in disasters to help people, and there's a lot of opportunity before and after disasters to get the data that you need to help people during a disaster. So I've been working in this field for, oh geez, like 20 years now. And worked with a lot of great students, undergraduates and graduate students, a lot of professionals in the military and elsewhere. And we basically help communities avoid disasters. And then once a disaster strikes, when it pertains to water infrastructure, help them basically pick themselves up and kind of get back on track. But something I never ever thought I would talk about. Policy, right? So I'm a civil engineering, BS of civil engineering, MS of environmental engineering, burnt out on school, went and got a job, came back, got a PhD in civil engineering, and then moved in you know, water and wastewater treatment and, you know, chemical processes. And here I am talking about policy. And the reason why is because I've been in enough disasters now and seen how research works to realize that in the absence of evidence, people will make decisions. And those decisions may have profound impacts on the safety and well-being of other people in a good way or a bad way. And so it's really important to understand that. One of the issues that we deal with in these types of chemical contamination disasters, where drinking water systems are contaminated by a chemical spill, like in West Virginia, where the chemicals were sucked up into the intake of the treatment plant, went through the treatment plant, and were distributed to 300,000 people across West Virginia, shutting down the state capitol for 9 days during the first week of the legislative session. So when all the lobbyists were in town, when all the politicians' families were in town celebrating, and that caused people to pay attention. The water also smelled like black licorice, like candy, and that was unnerving because you would smell it or take a shower and it would smell like candy. You were also told that it was not safe. But one of the issues is once that water passes through the treatment plant, it goes into the distribution system, right? The buried piping network goes through plastics, goes through metals, corrosion scales, all biofilms, all sorts of complexity, reaches maybe a water meter, passes through that. On the other side of the water meter, there might be other types of materials, goes into buildings, residential buildings, commercial buildings that have like multiple tenants. And so really, if you're trying to understand where chemicals go, you need to understand what they are, where they're going, where they stop, where they hang out, right? Where they sorb into and desorb, and then what levels are pose a health risk. And so all these issues are pretty straightforward, but when disasters happen from a policy perspective, we don't see that. So another issue too is like with wildfires or other disasters like tornadoes, 15% of the US population uses private wells. So when the water utility goes on TV and says, don't use your water because it may be contaminated, you don't have the private well utility, because it's just one household, right, going on TV telling that family not to use it. So there's this dichotomy between advice being given to communities that rely on large public water systems, and then there's everybody else who's kind of on their own during a disaster. Now, natural disasters, and I'm sorry for this being US centric. We do have great partners up north. But natural disasters affect thousands of communities each year in the United States. We know from over a 10-year period in the US alone, there were 351,000 chemical spills. A lot of them were petroleum compounds, and many of these impacted US water bodies. So you hear a lot about source water protection, protecting watersheds from spills or contamination. What I'm really focusing on is the distribution system network. And to date, in the US alone, we've had about 8.8 million acres of fire burned in wildfires, about 52,000 fires in the US, 17,000 structures, and most of those that have been destroyed were homes. So it's been a pretty significant year, especially in California, where 4 of the 5 largest fires occurred. And there's 2 fires that I think you'll be interested in. One is the Tubbs Fire of 2017, and the other one's a Campfire. So when wildfires happen, and I'd never been to a wildfire disaster zone until 2018 when we got called in to California, it is pretty eye-opening, because you will go down a cul-de-sac of where there would be 20 houses, and you'll see 18 debris piles on top of a foundation with children's play toys out front, with a door standing there with welcome on it, and then everything behind it is burned down. And it really has an impact, because you realize that people's lives are affected. Like, there are families there that they had to move, and everything's up in the air for them. One of the issues, however, is water contamination. And water contamination, we can look at the Tubbs Fire of 2017. This is in Santa Rosa, California. The Tubbs Fire was large, and it basically came down from the north of the top of this figure, and then moved south towards those red dots. and it moved towards the city of Santa Rosa. And it stopped right on the outskirts. Only about 20 people were affected where their homes burned down in Santa Rosa, and not burned down, that were left standing. And what that means is that these homes, 20 homes, were surrounded by debris piles on slabs. About a month after the fire, somebody called the city and said, hey, my water smells funny. Can you come out and test it? And the city sent somebody out and did testing and found benzene at a level above the California state limit of 1 parts per billion. The federal US limit is 5. So they found benzene above 1, and they issued what they called a do not drink, do not boil water. So don't boil the water because it's a volatile organic compound. It will go into the air and you'll be exposed to it. Don't drink it because it's above the safe drinking water limit for California. Well, it turns out that subsequent tests revealed much, much higher levels of contamination. And to put that in perspective, 40 parts per million, 40,000 parts per billion of benzene was found in the drinking water, in the distribution system network. And it wasn't in the water treatment plant. It was just in the buried piping network and in people's homes that were left standing. So this was really interesting to the city. They thought about, okay, well, we're just gonna have to remove and replace these 5 miles of pipes that we found the contamination. Instead, they were able to flush a lot of it out. Some of them they had to remove, and they spent about $8 million. They did testing. They found really a lot of differences, right? So when you go, it's like a research project. When you go into a situation, you don't really know what you're looking for, and you find something, now you got to figure out why it's there, where is it, how to get it out. And you're talking rapidly. We're not talking like a 3 or 4 year PhD on this topic. I mean, people want to get back in their homes like next week, but they don't want to pay $1 bazillion to rip out everything and put it all back in the ground. So there's these conflicting priorities about science and returning to normalcy. Now, the Campfire that we were involved in occurred in 2018. And the Campfire was simply just a different scale. And so you probably heard about it. There's a Netflix documentary. There's a whole bunch of other documentaries. The Campfire started in a place near Concow, and right kind of in the middle of the screen where you see Deadwood, and basically spanned out to the left and basically raked across Paradise and went north and went south towards Chico. They thought actually it was going to go into Chico, which is a city. And it also went to the right towards Yankee Hill. Now, Paradise used to have a population of about 26,000 people. In a span of like 3 hours, 14,000 homes are burned down. 3 hours. Like, we hear about these wildfires that are raging in the US for weeks, right? And they knock down like 300 homes. The Campfire destroyed, burned to the ground, 14,000 homes in about 3 hours. And people were basically racing off the hill from Paradise towards Chico. This is a map of the town of Paradise. And every red dot is a destroyed structure. So typically you see these maps as pictures of buildings, right? But here red is bad, it's destroyed. There are green dots, and you can see them a little bit. If you look very closely, green dots, those are standing structures, okay? So these standing structures, as I said, like one home on a cul-de-sac of 20 homes, there'd be one home standing still. The trees, the yard, the grass is out, the lawnmower's out in the front yard, and then all around it was like devastation. The public water systems, these are the regulated public water systems that provide water to, over, I think it's like 250 people per year. They were impacted. There were multiple water systems. Paradise Irrigation District, the Paradise water system, had a service population of about 26,000. After the fire, it reduced by 96%. So they had the infrastructure for 26,000 people, but nobody was there anymore. And so they had all this stagnant water and dead water. Another water company, Delaware Water Company, was there. They had multiple public water systems, and they lost customers homes. Like most of the people were able to get off the mountain. Private wells, there was over 2,400 private wells impacted. There really isn't any data about the testing for that, how many were contaminated, how many were not. That's because in a disaster, really nobody pays attention to the private well owners. They're on their own. And that was too big of a lift for the state. So, what I talk about here, policy is really important. And what I mean by that is these are decisions that are made by agencies on the fly, right? If there's no playbook for it, you get a whole bunch of people in the room who may or may not have the expertise to make that decision. They make a decision, they push it up the chain of command, and then it goes out into implementation. So on November 9th, for example, the PID, the Paradise Utility, issued a boil water advisory because they lost pressure. On November 11th, this Delaware Water Company, which is 1 mile away from the Paradise Utility, lost pressure. So they issued a boil water advisory. A few days later, they lifted it. There was evacuation orders. Nobody was allowed to be in the area. December 5th, the Delaware Water Company, for some reason, it was never disclosed in court documents or anything, they collected water samples for benzene testing. And on the 19th, 14 days later, because they didn't pay for rush turnaround, they paid for the cheapest 14-day commercial laboratory result, they found benzene was present above safe limits in 2 of its 3 water systems that they tested. So Paradise Irrigation District, not the state, not Delaware, issued a do not drink, do not boil water advisory for their people. And they said, look, we're not taking any chances. Well, the state was a little conflicted by this because they didn't authorize it. And they didn't want to issue an advisory for this private water utility called Delaware Water Company. So they put out a press release saying, we know there's differences, everything's okay. There was another press release by the private water utility that had contaminated water, unsafe water in its system, and they said the state hasn't told us to do anything, so therefore we're not. Well, the Paradise Irrigation District was getting questions because some people who were served by the Paradise Irrigation District had family that were getting water from the Delaware Water Company people, and Delaware Water Company's water was as contaminated as Paradise's water, but the public water system wasn't telling its customers that it was contaminated. And why weren't they telling it? Because the state said they don't have to. So this is a policy decision. And, late January, we told them that, they were talking to us and we said, look, you need to tell them. And the state basically said, well, we don't think that there's really that much contamination. And 2 weeks after having that conversation with me, they found 2,217 parts per billion of benzene in Paradise's water. So 500 is the RCRA, federal hazardous waste threshold for liquid characteristic waste in the US. And they found 2,000. So on March 5th, the state issued a press release claiming that this private water utility never, ever had contamination, which wasn't true because they had data that showed that they did. We called them, then they issued another press release saying that, well, there hasn't been any contamination since early on. Paradise Irrigation District basically was almost forced to only look for benzene. During this time, Paradise was being asked like what you should test for. They came to us and they said, how do we get ourselves out of this? We say you have to test for benzene and all these other chemicals because we really don't know what we're looking for yet. And the state basically said, well, that's too costly. We're not doing that. Just tell them to test for benzene. Well, Paradise found methylene chloride and other chemicals above safe limits when benzene wasn't there. And on March 9th, that came to a head when the state tried to legally force Paradise by a permit amendment only to look for benzene and not to do any more testing for other things. The county health department, right, that oversaw all the water, the public health in the county basically had enough. And on March 19th, they came out and issued a water advisory that said, do not drink, do not boil for the whole county, which included Delaware Water Company customers. So you have the state, you have the county, you have one water utility, you have another water utility, and then you have private well owners, right, who are kind of not on this page because they weren't being helped. March 22nd, California Department of Public Health shows up. They did a study and they exposed state employees to contaminated water from the town of Paradise on purpose because they didn't believe that you can't smell benzene at levels that could be harmful. And so this study kind of slid out and on email, and we picked it up and we were like, oh my gosh, did you have IRB approval? And they said, we don't need IRB approval. And if you read the report, and we post on the website, it shows that people reported health impacts, like acute health impacts from being exposed to the water. So the next thing that happened was, more benzene was found by Delaware Water Company. And then the state toxicologist came out and said 26 parts per billion poses a short-term health risk to children. And as of March 23rd, the average concentration in Paradise was 31 parts per billion. And the average concentration in Delaware Water Company was about that too, but Delaware Water Company wasn't sampling. And they weren't sampling because they would go to the state and the state would say, you don't have to sample. So it was really interesting about how we had the same state, the same fire, a mile away from each other, different policies for different utilities. And so colleagues and I got involved. We went in primarily to help the town of Paradise because they're the ones that called us. When we realized what they were talking about, and they kind of didn't really know what they were doing, because you can't plan for these types of catastrophic disasters for small communities. It's only 26,000 people. We basically corralled the state, US EPA, FEMA, the firefighters, CAL FIRE. We put them all in a room, the health department. And we said, okay, this is what we're going to do. We're going to go audit the system to see what needs to be done. We're going to give you a plan, and then you're going to implement it. And so that's what we did. We went in and we looked at everything. Dr. Caitlin Proctor, building plumbing expert. She's next to me. Dr. Amisha Shah, she's an analytical chemistry, environmental engineering expert. David Hughes, sociologist. Armin Sabahi, he's a statistics person. And so we brought him in because we want to know if we're going to sample homes or parts of the system, what's our N? How many samples do we need, to be statistically significant in our conclusions about things? And then Jun-Suk Lee, who's on the far right there in the green with Manhattan College, he was a hydraulics expert. So just to give your engineers, right, some idea about what's going on, we need to show, if I'm not going to show you a piping network, I need to talk about the piping network. 35% of the town of Paradise's water system was PVC distribution pipe. 33% was steel. Actually, most of that PVC was installed the year before. And it was buried water mains. They had about 10,600 service lines. And as it turns out later on, what we found out is that more than 50% of the service lines were contaminated. They were plastic, which means you couldn't decontaminate them. You had to remove and replace them. So they basically been digging up service lines since 2018 and replacing them. The types of damage we saw, 90% of their 172-mile water distribution system was depressurized for weeks. And that's because when your employees' homes burn down after you run out of town, you're not coming back and repairing that hydrant. You're relocating your family so that they can survive, and then you go back, right? So there was this delay in workforce and labor. They had hundreds of leaks for weeks on end. They just had water leaking out of their system. Some of these pictures here, the lower left is a plastic water meter. On the lower right is a metal water meter. And then on the top right, that's a high density polyethylene service line. And you'll see that it's melted on the inside, got too hot. And then on the right-hand side, what happened was a plastic material melted upstream of this service line and then flowed down into the plastic and then crystallized. And so the infrastructure was subjected to extreme heat. So, many people don't really understand about the scale of contamination. It was hazardous waste level scale contamination. And one of the issues was the acute exposure to children. So there were children in the area still living in these standing homes because the insurance company says, well, you can still live there, so we're not going to pay for you to go to a hotel. You have water, it's not safe, but you still have water to flush toilets, so therefore, we're not paying for you to do that. So you had families, and many of them are friends of ours now, and we talked to, and they were concerned about the safety of their families. There's a paper that's published. It's free. You can click on it. I'll post this presentation on my website. So one of the questions that everybody asks is, where's the contamination coming from? And there were 3 hypotheses. One is the in situ thermal decomposition of the plastics. So as the fire came close to, let's say, a water meter box, the plastic pipe service lines in there heated up and started decomposing, generating these contaminants, and then directly leached into water. Next week, we're going to have a paper out that concludes what we found, and I think it's worth checking out. Another issue was smoke being in the air, and if you had a broken hydrant and depressurizing, that smoke would then get drawn into the hydrant and then mix with the water, and you would have this VOC, SVOC contamination. And another question was if the structure was burning down and you had depressurization, the structure materials would be sucked into the plumbing water. That plumbing water would be sucked into the distribution system, and then that would cause contamination. So all the basic fundamental phenomena that we learn about in school, chemical processes, fate and transport, all are at play here. The EPA engaged, US EPA Federal Research Arm engaged about 6 months into the fire because we wanted to estimate how long it would take to decon, like plastics in situ. The state wanted to flush, just flush. And, my prior experience with plastics and contamination, decontamination led me to believe that wouldn't work. That was not a good idea on the time scale. We figured out that some of the situations with EPA's help would have required over 286 days, 2 gallons per minute per pipe, 24 hours a day to remove the contamination that was in the plastics that were in the system. Standing home public health implications are really important. One of the issues, as I said, during the beginning, was that when people don't necessarily know what the right answer is, they make decisions anyways. California told people to smell the water and not test it to determine if it was safe. I kid you not. That literally came out in a press release from the state of California, and people did it and said they felt bad after. And then that is why California sanctioned a study by the California Department of Public Health. And right after they completed that study, they came out and said nobody should smell the water. They should chemically test it. So the issue with disaster response is that the people that are making the decisions or in the room may not have the expertise needed to understand the implications of their decisions. And that's really important. Delaware Water Company had 530 parts per billion of benzene in their water system, never issued water restrictions. People used it. Homeowners called me. The state refused to force them to, and they could have done that by invoking the U.S. Safe Drinking Water Act public notification rule, but they chose not to. Some customers thought it was fake news. They thought that the contamination wasn't there, that it was all a ploy to get people to move away so that other people could buy up the land. And that was challenging. So 6 months after the fire, people didn't know how to test to determine if their plumbing was contaminated. 70% of the population that we surveyed had mental health concerns. They had stress, anxiety, or depression. that they specifically said was associated with water contamination. Like they were so nervous about the water to them or their families that they were concerned. There's a whole bunch of other information that we uncovered. We did go in and conduct a workshop training because homeowners didn't know how to handle like responding and recovering from the disaster. So we went in and we trained them. We did a survey too, and as I mentioned, mental health was a really significant issue. People didn't trust the organizations involved, primarily because none of the organizations involved, except for, say, the Paradise Water Utility, stepped up and was transparent in their decisions. Some of the issues, right? So some of the issues we see after disasters, we see with lead in drinking water under routine situations. So I don't know if you know, but in the US, there was a big issue with people flushing faucets before they would take a lead sample. And after the disaster in California, what happened was that the state told commercial laboratories to go help people take water samples to determine if their plumbing was safe. And so the commercial laboratories knew that they couldn't necessarily go out and do that because they didn't have the manpower. So what they did was they put instructions together, gave them to the homeowners, and those instructors told people to flush their faucets for 10 minutes before they took a sample. So all this money was spent at commercial laboratories, and the data was generated, and it had no value for building plumbing contamination. And homeowners didn't know that. And when they found out, they were angry. Now, the state didn't necessarily want to deal with that because it was just another thing that came up that they kind of fumbled through, and they wanted to focus on things that they felt more comfortable controlling. But what you really have to realize is that the focus of disasters should be the people, not I'm an engineer, I'm going to look at the water plant, I'm going to look at the distribution system. Like if somebody's not pulling their weight on some other issue, you don't just leave it over there because generally it's closer to the public and that's actually something they need. So that's our experience. We came out with a testing policy for plumbing systems because 7 months after the state hadn't come up with anything. The week before we were going to issue it, we gave the state a copy. They didn't respond. And then 7 days later, they issued their own, which said, take a benzene only, cold water, immediate sample from your kitchen sink one time. And that will tell you if your hot water and cold water system are ever contaminated or will ever be contaminated, which was ludicrous. So it didn't follow science. It's like going into the middle of New York City, picking a fire hydrant, taking a sample and saying the entire New York City has safe water at every point, right? I mean, there's just no logic associated with that, but logic isn't necessarily what sets policy. And so we worked together with a number of universities to put stuff together. We worked together with a number of other universities on site, and these are some great people that we worked with. We went in, we trained people on water sampling. And then 8 months after we warned the state of California that they needed to test building plumbing systems, University of California, San Francisco came in. They did testing and found 11 months after the fire, there was still contamination in people's homes. So 1 year later, after the fire, less than 10% of the people returned. They have now been classified as a rural community. There was 11 homes out of 14,000 that were destroyed. 11 homes were rebuilt. And so it's still going on. They're recovering. They've removed all the contamination from the public water system, but private water systems still likely have contamination because they didn't necessarily pay to remove their contaminated service lines. This year, there were fires in the US. There was contaminated water systems found in California. Two down in Boulder Creek, California. The utility and the state told people to bathe in the water. They had no data showing that the water was unsafe, which is not the way you're supposed to protect health. And then they found contamination 2 weeks after telling people to bathe in the water and told people not to bathe in it. So again, policy is not necessarily set by data. It's set by people making decisions that may be detached from data. Hurricane Maria occurred in 2017. And the reason why I bring this example up, first of all, it's an amazing paper done by researchers at Johns Hopkins University. But 2 months after the disaster, the utility, FEMA, and the EPA all had different messages about whether the water was safe or unsafe to use. In 2014, kind of the first public disaster response I did, there's a case study out there that talks about how there was all sorts of conflicting information. CDC said the water was safe. The state health department said it wasn't. The county health department said there's not enough data to make any decision. And the utility basically said the water was safe too. So it's really interesting from a policy perspective that decisions are made that may or may not have evidence supporting them. And this is where I think impact can happen, right? So what can we do? Well, in universities, we can train people to be prepared for the unknowns, right? We're not going to train a whole bunch of PhDs and plant them in every agency around the world, but we can make people comfortable with not knowing something and figuring it out. And I think that's what disaster response needs. There's also some work that needs to be done in bench scale testing. Some of the stuff that we're doing, we took plastics, we heated them up, we didn't burn them, to see what types of contaminants are generated during heating. And next week we'll have the study out on the street, but the findings are significant. So there's very simple things that can be done to answer some low-hanging fruit to help people during disasters. And with that, I'm going to stop talking and check out, I think the chat's blown up. I haven't seen any of that. So I'm going to stop talking and I'll take any questions if Carl has any.